Yes, feeder conductors from separate services with different amp ratings can meet in a shared J-box ahead of the branch circuit disconnecting means under specific conditions. These conditions ensure safety and compliance with electrical codes. Both services must be derived from the same transformer system or transformer bank. This is a fundamental requirement. The combined ampacity of the feeder conductors in the J-box must be greater than or equal to the largest service ampacity. In the example given, that would be 1600 amps. This ensures the conductors can handle the potential load. The feeder conductors must be protected by a common overcurrent protective device rated for the combined ampacity. This protects the conductors from overloads and short circuits. The J-box must provide isolation and protection for the feeder conductors from physical damage in contact with other conductors. This is to prevent electrical hazards. The J-box must be readily accessible for inspection and maintenance. This allows for easy troubleshooting and repairs. This requirement is specified in the National Electrical Code, specifically NEC Article 230.90. A3. It states that where more than one service is installed, each service shall be provided with a separate disconnecting means at the service entrance. The disconnecting means for two or more services shall be grouped together and identified. Where more than one service is supplied from the same service equipment, the disconnecting means shall be contained in a single enclosure or grouped in a common location. This code section addresses the grouping and identification of service disconnecting means. Additional considerations include the feeder conductors should be sized appropriately for the load requirements of the building and the ampacity of the protective device. Proper sizing is crucial for efficient and safe operation. The J-box should be large enough to accommodate the splices and termination of the feeder conductors. Adequate space is needed for proper connections and heat dissipation. Proper grounding and bonding must be provided in the J-box and throughout the electrical system. This ensures a low impedance path for fault currents. It is recommended to consult with a qualified electrician to ensure compliance with all applicable codes and standards. A professional can assess the specific installation and ensure safety. Firstly, ensure that both services originate from the same transformer bank. This is the cornerstone of allowing the feeder conductors to merge in a shared J-box. Secondly, calculate the combined ampacity of all feeder conductors entering the J-box. This total ampacity must equal or exceed the rating of the largest service, which in this case is 1600 amps. Thirdly, install a common overcurrent protective device. This device needs to be rated for the cumulative ampacity of the joined feeder conductors. Fourthly, the J-box itself needs to be robust. It should effectively isolate and shield the feeder conductors, protecting them from any form of physical damage or inadvertent contact with other conductive elements. Fifthly, ensure the J-box is easily accessible. This facilitates convenient inspections and routine maintenance. Sixthly, adhere to the National Electrical Code, notably Article 230.90. A3, which mandates separate disconnecting means for each service at the service entrance grouped and identified. Seventhly, carefully size the feeder conductors. They must align with the building's load demands and the protective device's ampacity. Eighthly, select a J-box with ample dimensions. It should readily accommodate all splices and terminations of the feeder conductors. Ninthly, implement comprehensive grounding and bonding within the J-box and across the entire electrical system. This establishes a low impedance path for fault currents. Tenthly, engage a certified electrician for expert guidance. They can ensure full compliance with all relevant codes and standards. The function of a J-box or junction box is multifaceted. Primarily, it serves as a protective enclosure for electrical connections, shielding them from environmental factors like moisture, dust, and physical damage. This protection is critical for maintaining the integrity of the electrical system and preventing potential hazards such as short circuits or electrical fires. Secondly, the J-box provides a centralized location for making connections between multiple conductors. This simplifies wiring layouts and makes it easier to manage and maintain the electrical system. Instead of having scattered connections throughout a building, they are consolidated within the J-box, making troubleshooting and modifications more efficient. Thirdly, J-boxes play a crucial role in ensuring electrical safety. By containing and insulating electrical connections, they reduce the risk of accidental contact with live wires, protecting individuals from electric shock. Additionally, properly installed J-boxes can help prevent the spread of fire by containing any sparks or arcs that may occur during electrical faults. Fourthly, J-boxes are essential for complying with electrical codes and regulations. These codes specify the requirements for installing and using J-boxes, ensuring that electrical systems are installed safely and correctly. Compliance with these codes is not only a legal requirement but also a crucial step in protecting people and property from electrical hazards. The materials used to construct a J-box can vary depending on the application and environment. Metal J-boxes, typically made of steel or aluminum, are commonly used in commercial and industrial settings due to their durability and ability to withstand harsh conditions. They provide excellent protection against physical damage and are often required in areas where there is a risk of fire or explosion. Non-metallic J-boxes, made of plastic or fiberglass, are lighter and more resistant to corrosion, making them suitable for residential and outdoor applications. They are also less expensive than metal J-boxes and are easier to install. The size of a J-box is determined by the number and size of the conductors that will be connected within it. The electrical codes specify the minimum size requirements for J-boxes to ensure that there is enough space for the conductors to be properly installed and that the connections are not overcrowded. Overcrowding can lead to overheating and other electrical problems. When selecting a J-box, it is essential to consider the environment in which it will be installed. In damp or wet locations such as bathrooms or outdoors, a waterproof J-box is required to protect the electrical connections from moisture. In hazardous locations, such as areas with flammable gases or dust, explosion-proof J-boxes are necessary to prevent explosions. Installing a J-box involves several steps. Firstly, the power to the circuit must be turned off to prevent electric shock. Secondly, the J-box is mounted to a wall or ceiling using screws or other fasteners. Thirdly, the conductors are fed into the J-box through cable clamps or connectors, which secure the cables and prevent them from being pulled out. Fourthly, the conductors are connected using wire connectors such as wire nuts or terminal blocks. Finally, the J-box is closed with a cover to protect the connections. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault currents to flow back to the source, tripping the circuit breaker and preventing electric shock. Bonding connects all metal parts of the electrical system together, creating a lower impedance path for fault current. Grounding and bonding are typically accomplished by connecting the grounding conductor to a grounding electrode, such as a ground rod or water pipe, and by bonding all metal enclosures, raceways, and equipment together. Regular inspection and maintenance of J-boxes are essential for ensuring the safety and reliability of the electrical system. J-boxes should be inspected for signs of damage such as cracks, corrosion, or loose connections. Any damaged J-boxes should be replaced immediately. The connections within the J-box should also be checked periodically to ensure that they are tight and secure. Loose connections can cause overheating and other electrical problems. In summary, the use of a shared J-box for separate electrical services is permissible under specific conditions that prioritize safety and code compliance. These conditions include ensuring that both services originate from the same transformer bank, the combined ampacity of the feeder conductors meets or exceeds the rating of the largest service, and a common overcurrent protective device is in place. The J-box itself must provide adequate isolation and protection, be readily accessible for inspections and maintenance, and comply with the National Electrical Code, particularly Article 230.90. A3. Additional considerations involve proper sizing of feeder conductors, selecting an appropriately sized J-box, and implementing comprehensive grounding and bonding. Consulting with a qualified electrician is crucial to ensure adherence to all applicable codes and standards. The J-box serves as a protective enclosure, a centralized connection point, and a critical component in ensuring electrical safety. Its construction materials, size, and installation methods are determined by the specific application and environmental conditions. Regular inspection and maintenance are essential for maintaining the integrity and reliability of the electrical system. This approach ensures a safe and compliant electrical installation.